and that gets your reflection rises, yeah? So how do we do that? Well, we look at distances. This point must be the same distance away from the mirror on the other side. Now I'm doing this by eye, but you have a ruler and you've gridded paper, so it's easier. Stop. This fella looks at himself in the mirror here about, and then this fella's the furthest from the mirror, so his reflection is going to be the furthest on the other side, and it looks something like this. Yes? That makes sense? Now, there's a couple of words that go along with mirror lines. This is something called the object. And the new one that's created is called the... Yeah, the reflection makes sense, but it's actually called the image. Sometimes this is called pre-image, an image, but that's probably not the most important thing. The look of it is far more important. Right. Also, if these have letters, so A, B, C are the corners of this triangle, the vertex are corners of the triangle. The ones over here, I can't call that A because it's not A anymore. It's A that's been reflected. It's called A dash. This is C with a little dash, and this is B with a little dash. And that's how they show that it's not the same as the original. Now I'm looking for you to copy this in your workbook. You can decide how many boxes you put it away from the mirror line, but I also want you to draw it down here when it's reflected in this mirror line. See, can you draw it there and what it would look like? So remember, each point must look at itself in the mirror and be the same distance away. So this point C, whatever way your mirror is drawn, must look at itself in this mirror and be the same distance away over here, and you can figure it out. Yes, Tyler?
Is the mirror line dotted?
I prefer if it's dotted, yeah. So it was here, wasn't it? This guy's got to be down here, look at itself directly in this mirror line. This guy's got to look at itself, so this would be C dash, B dash, and then A is the furthest one, so it's going to be the furthest one on this side, A dash, and it's got an upside downy triangular look. Now some of you drew the one over here, that's great as well. This is also an image. Some use a double dash, but that's not necessary. That's usually when an image is reflected again. Okay, so that's if it's not on a Cartesian plane or a coordinate diagram. Let's do it now on the coordinate diagrams. I'm going to reflect this first one in the line y is equal to negative x. I'm going to do that one in a second. I'm going to reflect this one in the line, let's pick a nice line, x equal to 0. And reflect this one y is equal to 1. Okay? Let's start with the one in the middle. Reflecting the line x equal to 0. If I draw this mirror line somewhere, where are we going to draw it? X equal to 0. Where do you think a line x equal to 0 is going to be? This line? The x-axis? Luca? Which one? Like this? No. This? X equals... It's in IXL, yeah, you should. It's a straight line somewhere. It's a line somewhere. Where is x 0?
0 is the middle.
0's here, right? So I need a line x equals 0.
Oh, like
So it has to be a line, it's the x-axis, is it?
yeah.
No. It's the y-axis. It's this line. Why is that the line x equal to 0?
It's reflected.
Tyler? No, this exists. Yeah, this is the line. It's just on top of the axis. It's good thinking, though. But that's the line on top of the axis. So x equal to 0 is the y-axis. But why? Well, what's this point here? What's this point here? No. What's its coordinate? 0, 1. What's this coordinate up here? 0, 4. This 0, 6. all the x coordinates along that line are 0. All the x values along this line are 0. So that's why it's called the line x equals 0. Sometimes it's called the y-axis as well. But the more official title is the line x equals 0. Okay, so if I have to reflect this triangle in this mirror line, so my mirror line's right here, I am going to do just as we did, count some boxes. This guy is 1 box away from the mirror, so he's 1 on the other side. He's over here. Its new point is 1, 1, if you want to write in the points. This guy is minus 4 here, so is it going to be 4 over on this side?
Yeah.
You sure?
No, it'd be 5.
Well, we can just count the boxes. I think it's, well, no, you see, there's only 3 boxes to here. It is 4 boxes to the line. You're thinking of, yeah, in general, you can't rely on that. But if it's right on the axis, it is 4 on this side. 4, 1. And then the last one, it was at here, so it was 2 boxes away. It looks itself in the mirror. It's 2 boxes away. It's over here at 2, 4. And then I join these together, and Bob's your uncle. Image here. Bob is your uncle. Yeah. It's an Irish thing. Okay. Not too bad. Let's do this one next. Triangle 3 next. Reflected in the line y is equal to 1. Well, if this is the line x equals 0, where's the line y is equal to 1? Is it horizontal or vertical? Horizontal? Vertical. Which one? Vertical. Horizontal. Well, this is where y is 1. And there's already a bit of a line there. It's a bit of a dash. And it's that dash continued. This is the line y is equal to 1. For the same reason that was the line x is equal to 0. All the points along this line, like for instance here is 3, 1. Here is 5, 1. Here is 2, 1, 1, 1. What's the in common? The y value is always 1. You can just think, where is it goes through the y-axis at 1? Y is 1 all along that line. So now I have to reflect across this line. So where does this point go? Give me a coordinate for that point.
Positive 1, negative.
Is it here?
No, it'd be 1
No,
above.
it should be here or here.
There.
So I don't rely on my eye. I just going to count my boxes. So there's 1 to here. So you have your boxes. I know there's none here, but there's 2 boxes here. So it's got to be 2 boxes away on the other side. Over here. It's got to be the same. A reflection is always the same distance from the mirror as the image. This one is 2 boxes away. 1 to here, 1 to here. So he's also 2 boxes away. And this fella's a lot of boxes away from. How many boxes is this guy from the mirror?
1, 2, 3.
Is it 4?
Yeah, 4.
5, yeah. 4 to the x-axis and then 1 more. So he's got to be 5 on the other side. So that's right up here at 6. And now you understand why I got you to do 6 on your axes. Because this was coming up. So what did we do? We just counted the boxes to the mirror line and went the same the other side, going straight at right angles to that, perpendicular to that mirror line. So here was our mirror. This is our image. It's upside down, like in a mirror. So you're copying these on your diagram. You should have your diagrams ready. And we got one more to do, and that's that simple line y is equal to negative x. Those of us who did it on IXL might know where that line is. Where's the line y equal negative x?
It'd be under.
Down here?
No, on this.
Here?
Yeah.
Like this?
Any between them, because it's a negative. It'd always be a negative. Wait, why?
Y is equal to negative x. It's not a number anymore. It's not one particular number. When it's x equal to negative 3, it's here, and it's just this line through x. When it's y is equal to negative 2, it's just this line through here. But this has got y and x in it. Y and x.
Is it diagonal?
Yes, it's diagonal. It's a diagonal line. Which way? Is it uphill or downhill?
Why first?
It is downhill. Why is it downhill? It's this line. If I put some dots here, and then I'll put the coordinates on them. So the coordinates here are minus 1, 1, minus 2, 2, 1, minus 1, minus, or 2, minus 2, 3 minus 3, 4 minus 4. It's this line that joins all these points together. What do we notice about the points? They're constants, yeah. Aren't they the same number? But one is negative. So it's always 1, 1, but 1 is negative. So that's what y will equal x, but x will be the negative version of y. That's what this says. So it's this diagonal line which goes through all the opposite points. Which means what? Just try and draw a perfectly diagonal line, like 45 degrees.
No, but like, how do we draw the hat?
Oh, we'll come to that. What would be the one going this way then?
X
X
is equal to
equals
negative
minus y.
Nope.
X equals y.
Yes, x equals y. Because it will go through 1, 1, 2, 2, 3, 3, 4, 4. That is the same, y equals x, or x equals y. So that's the name of that line, where x equals y is this positive diagonal line. Okay, we've drawn the mirror. I know I've not done a dotted line, but how am I going to reflect the object in it?
That way.
It's got to go down here, yeah? Yes, you were correct. It's got to go directly, every time you look in the mirror, do each point, point by point. You look directly at the mirror and your image is directly on the other side. So this fella, he looks directly at the mirror and his image is directly on the other side over here. Watch what happens to the point. This point is 1, 1. What's this point? Minus 1, minus 1, yeah. What's going to happen with this guy? He looks directly at the mirror. His point is 4, 1. He looks directly at the mirror.
Minus 1.
Now the temptation here,
Minus 1.
yeah, the temptation is to go minus 4 minus 1, yeah? Minus 4 minus 1 is here. That doesn't make sense. But minus 1 minus 4 does make sense down here. It's down here. Now, it might look right in my scale, but it should be around down here. Minus 1 minus 4. So he looks at the mirror, looks the same distance the other side. So we do it one by one. This guy looks at the mirror and goes the same distance the other side. This is the point 1, 4. Judging by my patterns, where is he going to land up?
Wait.
Yes?
Minus 4 minus 1.
No, minus 4, minus 1. Yes. Minus 4, minus 1. So we swap the points. And it ends up here. And does that kind of, I know mine is a bit off because my scale is dodgy. I ran out of space here. Does that look about right? It would have to fold perfectly over that mirror. Notice that they always fold over where the mirror line is. And that is